Alright guys, so here is questions 6 through 10. Alright, we just did 1 through 5. Oh, nope, I'm sorry. We did 1 through 6. So 7 through 10. So number 7 says, there are 80 buttons in a container. Oh, that sounds very interesting. 80 buttons in a container. Okay, so if I know that there are 80 buttons in a container, it says, if 24 of the buttons are yellow, what % of the buttons are yellow? Okay, this is sending an alarm off right now that this is a % question. Remember I gave you strategies for %, right? I told you go ahead and label part, whole. Okay? I have a container of buttons. I wonder, it's asking me what % of the buttons are yellow. It's not asking me how many are there total. So I know I'm solving for a part. Now, if you guys just write X, that's not going to help you, okay? Be specific with your X. What does that mean? It's saying what %. So I'll just put a % sign. X represents what, right? I don't know. What % are yellow? So X % yellow buttons. I know that this represents the % of yellow buttons. That's what we're trying to solve. It also tells me that there are 80 buttons in the container. That sounds like a statement of how many there are total present. Okay? So that's my whole. 80 total buttons. Okay? Now it also says that 24 of the buttons are yellow. It can't be a total because it just said 80. So I know that must be my part. So 24 yellow buttons. Now, I told you, you may need to create information. But let's look if we need to create information. If you look at your two parts, those two P's, if they match, meaning it says yellow buttons and yellow buttons, you don't need to create another part. These match, so I can set up my proportions, okay? So I can go ahead and set up my proportions since they're telling me the same thing. My P24 goes for my part, okay? I know that a % is always out of 100%. I know I'm looking for the % because I don't know. That's what I'm trying to solve for. So X goes up there, all right? And then it also gives me my whole of 80. All right, so I told you guys there's two strategies you can do with this. You can cross multiply and divide by the unused number, and you can scale, okay? I'm going to do both. All right, so I know that I'm going to have to find a scaling factor. Don't know what the scaling factor of this number and 24 is because I don't know the unknown. That's X. So I'm going to use 180, and I told you always divide the bigger number by the smaller number to find your scaling factor. And in this case, 100 divided by 80 is 1.25. Okay, so I know I'm going to have a scaling factor of 1.25, but I don't know if I multiply or divide. So let's look. I always want to go toward my X, so I'm going to draw my arrow toward my X. I'm going to do the same thing for my denominator. So if I look, going from 80 to 100, I'm going to a bigger number, so that means I need to multiply. So I'm going to do the same thing on the top. So let's check 80 times 1.25. It does give me 100, so we were right. So let's do the top. 24 times 1.25. X is equal to 30% of the buttons are yellow. And that's the strategy I'd like for you guys to use on your test as well because it will help you, okay? Let's look at number 8. Number 8 says, Larry made $24 washing dogs. All right? He gave 40% of his earnings to his mom. How much money did he keep for himself? Okay, so again, I see a %, so this is an alarming going off saying, okay, Alex, you need to go ahead and write part, whole, okay? Right, part, whole. So it says that he made $24 washing dogs. But I don't want to start with that piece of information because we want to figure out where does my X go, right? It says how much money did he keep for himself? Well, that's not telling you the total. It's saying how much of a little section is he going to keep for himself, because he gave some of it away. So I don't know the part. We wanted to know what he kept for himself, because it doesn't tell you what he kept. So this is the amount of money he kept for himself, okay? It does tell you that he made $24 washing dogs. That's a statement, okay? That's telling you that's how much he made. That's total in all, okay? That's your whole. $24 from washing dogs. Okay? It also tells you that he gave 40% to his mom. Did he keep that 40% or did he give it away? He gave it away. So that's a percent. So 40% he gave away. Now, I told you here's the test. Look at your two P's. Do they match? Okay? So that 40% that he gave away does not match the X that he kept. He gave away does not match he kept. So let's start another P. Alright? So I like to be creative and I use the percents to help me solve. I know that the percents are always out of 100%. So if I know that he made 40% or he gave away 40%, that means he must have kept 60%. Because 40% plus 60% gives me a total of 100%. So I can say that he gave or he kept 60% because they're opposites. He gave 40% he gave away, 60% he kept. Now I'm going to look at the two P's that match. Okay, he kept, match. So I want to use that P and this P. I don't even need the 40% that he gave away. All right. So now I can go ahead and set up my proportions since I found my P's. Okay. So I've got a part over whole, a percent out of 100%. Okay. So I know that he kept 60%. 60 is always the percent. It has to be above the 100. And then X is the P. I don't know what that is. We're going to figure that out. And I know that he made a total of $24. Okay. So I apologize. I realized I didn't cross multiply on number 7. I'll go ahead and do that here. I'll show you both strategies. Okay. So we first need to find the scaling factor. So I told you always I'm going to look at 124. And I'm going to take 100 because it's my bigger number divided by 24. And I get a scaling factor of 4.166666. A lot of them, and a 7. Okay, I know this is a long number. You can do 4.17 and then maybe round later. Okay, because that we'll double check that. Okay, oops, sorry. So that's my scaling factor for my numerator as well. Okay, so if I check 24 times 4.1, I'm going to do a couple 6s and then 7. I do get 100%. All right. If I check the top, now here's the problem. We got to make sure we're doing this correctly. I told you that we always want to go toward X. So that's where my arrow is going to point. That means that's going to point in that direction on my denominator as well. So let's look. We're going from 100 to 24. That's going it down in a number. So that means I need to divide on the top and on the bottom. So now I can do 60 divided by 4.1 and do as many 6s as you can. I get 14.4. Okay, so X is equal to $14.40 is that he kept for himself. Okay, so again, let's check this with cross multiplication. Okay, the only two numbers that I can cross multiply are 60 and 24. So 60 times 24 gives me 1,440. Then I want to divide that number by my unused number. The only number that I haven't used yet is 100. So 1,440 divided by 100 gives me $14.40, which means that we did it correctly. Okay, so let's move on to number 9. Number 9 says, a pair of tennis shoes was discounted for 20%. If the discount amount was $14, what was the original price of the tennis shoes? So again, another alarm going off in my head saying I see percents. I know I have to do part, whole. Okay, part, whole. So let's go ahead and break this question down. Let's start with what it's asking for. What was the original price of the tennis shoes? That sounds like it's asking for a whole, okay? Because I told you if it ever says original or total or in all, that is a whole. So we don't know what the original price is of those tennis shoes, okay? That's what we're trying to figure out. Now let's go back and look at the two pieces of information they give us. It says a pair of tennis shoes was discounted for 20%, okay? So I'm going to say 20% discount, okay? And it also says the discount was $14. So if I write $14, I can also say that was a $14 discount. Now, again, here's our test. Do these two P's match? Does that say discount? Does that say discount? Yes, they do. That means I can go ahead and set up my proportion off to the right, okay? So I'm going to set up a part over a whole, some percent out of 100%. So if I look at the pieces I'm given, I don't know my whole, so I'll put an X there with the dollar sign because we're trying to find the price. I know my percent is 20%, and I know my part, which is $14. Okay? If remember I told you is over of, the way you would read it is that 14 is 20%. That's the discount. All right, and we're trying to find the original price, which was 100%. That's the total. All right, so again, start with 1420, and I'm going to divide the bigger number by the smaller number. And I get a scaling factor of 1.4. I'm going to round 3, okay? So that means the scaling factor will be the same for my denominator, 1.43. If I go, again, now we're going to look at the x. We always want our arrow to go point toward the x. So that means I'm going to make it point toward the 14 as my numerator, because that's what we're trying to solve. So if I'm going from 20 to 14, that means I'm going to divide by that scaling number. Let's check. Okay, 20 divided by the scaling factor of 1.14, I get about 13.98. That's because I rounded. Okay, so that's what I was talking about, like in number 8. We have a little bit of a rounding issue, which is okay. You guys can do a couple more decimals if you'd like, or you can round your number at the end, round that up, okay? So I'm going to divide 100 by the scaling factor of 1.43, and I get 69.9, which means I'm going to round up and say that $70 was the original price of the shoes. Okay, so $70 was the original price. All right.